screen as well now?
Yes, it's we can see.
All right, thank you. So good evening once again. So we had a bit of a break for 2 weeks. So we are going to now start our lesson or start a session basically. So it's basically the Oracle SGA that we are going to talk about today. And let me just put it to full screen. Okay, so again, just to emphasize on what our objective here is. So our objective here is to make sure that you get the right fundamentals, right? So some of the, I mean, you kind of experience this problem with some of our resources as well. When you don't really have that understanding about the fundamentals, it makes life a little difficult for you to catch up with the rest of the things, especially within the Oracle database. So therefore, our objective here is to make sure that we place those fundamentals right planning to you so that you'll be able to capitalize on those areas and then move forward. Okay, so taking that into consideration, today the session is all about the SCA, Systems Global Area. So we'll see how Systems Global Area helps, and then we'll talk about the components within SGA as well. So you may also find that I'm using a small label here that is Oracle AI Database 26, right? So we call it 26 AI rather. So that's the latest version which Oracle has announced in the last Oracle AI World. So so there have been many developments within the database arena. And before going into those areas, I think, again, we need to first understand the logics of the fundamentals, right? Okay, so when you are talking about the database, something that we can't forget is basically the database instance. So database instance is a compulsory component that is running within memory. Right. So when I say within memory, it may be in the physical memory. Sometimes it might get swapped as well, based on how you have configured it. But generally speaking, we could, we could say that the database instance is running on memory. So this is a memory component, therefore, that will have an attachment to the database or physical database as well. And then we make use of this database instance to let end users, we call it the end users or customers or whoever, or the client processes, connect to the database instance in order to fetch data from the database and also write changes to the database back. Okay, then we just take the pointer option as well here. Okay, right. So as I was saying, the database instance, so this outer box here, right, has the database instance, right? And then the database instance has various components, as you could see, right? So database instance comprises of the SGA, the Systems Global Area, the topic that we are going to discuss today. And it also has several other areas as well. Now, for example, we have something called as Program Global Area, which is more of a private environment or private area for the connections that we have, or the database connections. So when customers or when end users connect to the database, for their sessions, there will be separate PGAs or program global areas that will be created. So that's more of a private area. Now, for example, if you invoke a session, the session data will be maintained within these PGAs, right? So it will be kind of private to individual sessions. Now we also have something called as managed global area. So managed global area is something that might sometimes you might have not heard of it. So this MGA is more into processors. So for processors communication, right? So inter-process communication, they use MGA, but there are certain other cases where this particular component will be used as well. Now, for example, if you are running queries with parallelism enabled, right? So there will be a lot of multiple threads that will do their own work in order to complete a single task. And for that, you need to do some coordination work, right? So this coordination work is also going to happen through this MGA area, but it's kind of, is internal to Oracle. And this particular area will be initiated by certain certain sessions, and those will be the initiated environments will be dropped as well when certain operations are completed. Now, one thing, okay, when it comes to SGA, the one that we're going to talk about is a public area. So whatever you have within SGA is retrievable by or can be shared by the sessions that are getting connected to the database, right? So the PGA, which I talked about early, that is more of a private area, right? But when it comes to MGA, it's a mix of both, right? So some spaces, or we call them namespaces, can be shared by many processors, but some of the namespaces will be only occupied by a certain set of processors only, right? So those are some of the differences when it comes to when you compare SGA, PGA, and MGA. So we are not going to talk about PGA or MGA here today in this session. We are going to focus only on the SGA. Okay, and apart from that, you can also see that the database instance comprises of background processes and server processes as well. So when you establish a session as a end user, when you establish a session, then there'll be for you to get information, for you to store information, you will be getting the services from a process called server processes, right? So server process. So that will be sometimes dedicated to your session. Sometimes there will be pre-spawned server processes that will be catering to multiple user requests, right? So we will again not go into detail about those things today. And then we also have a background process that will probably, supplement or will support certain operations of the components that are running within SGA. And of course, the data will be retrieved from the database, right? So now when it comes to databases also, we don't talk about single tenant or sorry, not single tenant. We don't talk about non-CDB or non-container databases, but we'll be talking about container databases. So when you say container databases, it could be single tenant, where you may have a container database attached with a single pluggable database, or it could be a single container database having multiple databases, so multiple pluggable databases attached to a single database. So that is what you call multi-tenant database or multi-tenant or multi-tenant database, right? So multi-tenant container database. So I would say that when it comes to this instance that I'm talking about here, right, which SGA is part of it, right? Instance, when you are having a database or single container database, so there'll be just one instance attached to a container database, regardless of the number of pluggable databases attached to the container database. So for example, it could be a single tenant container database where you only have one pluggable database to the entire which is part of the entire container database. So you'll be having a single instance for that. But at the same time, you may have another environment where you may have hundreds of pluggable databases attached to a single container database, which we call the multi-tenant database, right? But still, for that also, you'll be using the same single instance. I mean, it's not the same, but one single instance, right? So regardless of number of pluggable databases that you have in a container database, so you'll be only having a single instance per container database, right? So that's what I want to highlight here. And then we also have, let's go to the next section, which we talk about the systems global area, right? So formally, this is also called as the shared global area, but nowadays we don't say that as shared global area, but instead we talk about, we say, SGA. So SGA is basically a set of shared memory structures, right? We'll go into detail about this, but you can see this screen as well, where you can see the database instance. Earlier in my previous screen, I showed you that how an instance would look like, and part of the instance was the SGA. Now we are going to go deep down, and we try to explore the components within SGA, right? So as I said before, SGA is a collection of shared memory structures. And so it has, you can see here, there are many components lying within SGA, which has taken some space, right? So, so therefore you have to define the SGA, right? You can give a limit to your SGA, and accordingly, the sizes of these components that you're seeing here can be adjusted. So some of these components will have a dynamic size. Some of these components will have a static size, meaning some of them might grow based on the demand, right? Some of them cannot, go like that. Okay, so it will have a static value, but of course, maybe with a parameter change, probably upon a database restart, we should be able to change such static size well. Okay, right. So this will have, this SGA will have memory structures which basically contain some control information as well as data. Some of these components will not really carry data, but it will support the communication process, right, between the client and the client and the database. So at the same time, some of these components will really carry data as well. Okay, right. And some of these components will have certain structures that will support the whole, query processing operations as well. Okay, right. Okay, so now we are going to, okay, let me just give you more introduction, at a very high level, what you see within your SDA. Although you can see certain components like the vector pool, the shared pool, buffer cache, right, and so on, right? If at a very high level, you can go into your database and figure out what is your capacity allocation or space allocation for this STA component. So when I say space allocation, I was telling before, instance resides inside memory. So hence, the STA is also part of it. And therefore, you have to understand that STA is also within the sitting within the memory. Okay. Right. So when you check the SGA from your database, you will find the total space allocated for SGA with this line called total system global area, right? You can see that in bytes, how much of space allocated there. So it will have certain other values indicated here as well, which I want to touch upon probably in our upcoming slides, right? So you can see fixed size is there, there are variable size database buffers and redo buffers, and also optionally, sometimes you might find in-memory area space allocations as well. Okay, right. So let's go to some other view, right? From the database, we could query the $SGA info to retrieve a few more details about what you have within your SGA. Okay, so I told you SGA will carry certain memory structures, and these memory structures will have sometimes data in it. Sometimes it will have information for client and database accessibility, right? So it could be from the SQL code that you want to run, the compiled versions of SQL codes, and then certain other information for optimizing certain tools that you run within the database. So all this information will be there within this structure. So let's go into detail later. But again, just like in the previous screen, you find things like the fixed areas, fixed SGA, and redo buffers, and so on, right? So more or less the same set of components that you're seeing here, in addition to some other stuff like shared IO pool size, right, data transfer cache, and so on, right? So on the rightmost side, you can see that whether it is resizable. So you can see some of the values that you find. For example, the fixed SGA size, you can see that it is no. So when you say no, that means this is more of a static value that it carries, right? The redo buffers, you can see it's no. That means your redo buffers value cannot be changed unless you do a parameter change and restart the database, right? So you can say buffer cache, it is yes. That means dynamically the size of the buffer cache can change. So likewise, okay, right. And okay, then we go to next screen. We talk about SGA components at high level. Again, I'm taking you back to one of the previous screens that we saw earlier, right? And it talks about the total SGA size, right? So you can see in that total SGA size in my case, now in this, according to this one, it's about, I think, 80. This is bytes, kilobytes, megabytes. Yes, about 800 MB, the total memory SGA. So this can be set separately, and that is what you are seeing here. So once that value is set, we'll see what is inside that, right? So you can see here, you have something called as the fixed SGA. So this total SGA is a total of all these components, right, that you find here. So the fixed SGA. So if somebody asks you what is fixed SGA, you need to say that. So it's basically a memory space that will be dealt by the background processes. Hope you can remember in the firstmost slide, or probably second slide, I explained you about the database instance. So in database instance, we came across a component called background processes, supporting various operations that Oracle does between the database instance and the database, database itself. For example, when you want to write something to the database, right? There'll be a background process that will get invoked, and the cache that you have or the change data that you find in your instance will be flushed to the disk process. So I'm not going to name all these processes and their tasks, because processes will be done later on. I mean, not today, of course, but in a subsequent session. Right. So the fixed SGA is a space where background processes will communicate. Right. So it's an internal space to Oracle. So we don't go and change fixed SGA size, and it basically carries things like the database instance state information, and if resource information such as logs, right? So information regarding logs will also be exchanged, and it's more of a memory space for the background process, right? So if you can think like that, that would be. And we also have something called as a variable size, right? Again, variable size can be seen here. So this variable size is the value given within the SGA for dynamic, for dynamicness. For example, maybe a particular component. Now we saw certain components like the buffer cache, right? The Java pool and so on. In that probably one of the screens that I shared with you before. And when particular component requires more memory based on the demand that you have in the database, one component might shrink itself and release that additional space to this other component where the demand is required. Okay, so that is what you call dynamic. So the variable size basically has indications that this is the space that you have where these dynamic components can get themselves adjusted according to the demand. Okay, right. Now, dynamic components, there are two exceptions here. I mean, exceptions in the sense because they are separately given, especially the database cache is separately given here, right? So if you take the dynamic components, it excludes two components. One is what you call the shared pool IO size. Now, shared pool IO size is actually used for large objects. Nowadays, we don't really talk about just large objects, but we use a term called secure files. So secure files is more or less the next generation large objects, right? So it is not a new thing to the Oracle database. It was introduced, I think, maybe in 11G or 12C. I can't remember exactly the secure files. So, however, now if you take a large object, right, or secure files in modern concepts, right, it basically can store large objects. It could be a large video that you want to store. It could be a large document. So likewise, you can store content within a single data column, right? So that is what you call large objects. And sometimes you might do operations, what we call path operations. So for these operations, only you will be leveraging this component called shared pool IO size. Also shared IO pool size. Right? So this shared IO pool size is currently available to be changed dynamically. So which means can be changed dynamically, but generally when you want to change values, you use or you leverage parameters, right? So there, if you want to change those values, then the parameters have to be dynamic as well in order to immediately change, right? So if it is not dynamic, if it is static, it requires a database restart. So similarly, this parameter called shared pool IO size, you could see that there is an underscore in front of shared pool IO size. So this indicates it's an underscore parameter or hidden parameter or undocumented parameter, which is not readily available for users to change, right? Anything starting with underscore is basically called as a hidden or a underscore parameter, which probably requires Oracle support attention before you do any change. So that's basically the generic guideline given by Oracle, because these are not normal parameters that we change. However, just keep in mind this parameter is still dynamic, right? So that means if you want, you can do a we use to change parameters, we use alt system command. So you can just carry out alt system command immediately to do changes to this parameter as well. So however, it is an underscore parameter which requires Oracle attention before you implement. Okay. So anyways, why we need this parameter? Only if you are dealing with secure, right, or secure dealing with direct path operations, where you might need attention in order to do optimization. Okay, and then we also have the database cache, right? So the database cache is also dynamic, right? But I'm excluding these two when you are calculating the variables, because database cache size is separately given below the variable size. Okay, so if you really take the variable size is you can take variable size like the what do you call the variable size. I mean the true variable size. Okay, variable size, that is this variable size line, and then also the database buffer. And it can also actually incorporate in-memory area. As why I include here is simply because in-memory area is optional, meaning if you enable in-memory only, you'd be able to see this line coming up, right? If you don't see it, you'll be only seeing the variable size in the database buffer. Yes. So the components will have the total size available for dynamic adjustments, right? So that is what I want to highlight here. Okay, so the database buffers that you see here is is enabled using a parameter called db cache size. Okay, and then we also have something called as redo buffers. You can see the redo buffers entry as well. So redo buffers is not dynamic; it's a static entry, and generally we don't do tuning on redo buffers unless otherwise it is exceptionally required. However, as I said before, since it is not a dynamic value. If you really want to change redo buffers, there is a redo log buffer parameter available, but it requires a database restart in order to change that value. So it's a static parameter. Okay. So these are the components at a very high level that you find within SGA. So I was just kind of explaining you what are these line items that you see when you type the command show SGA. So feel free to stop me if there is any question, because we have kind of a bit to cover. So I'm just trying to go through it. So if there's anything that you want to ask, you can ask as well. Okay. Right. So the missed area, or the area that we did not see here, is the in-memory area. So I told you that in-memory area is optional, right? So by default, if you just have your database installed, right, and if it is up and running and you check your show SGA command, you may not really see the in-memory area. So for you to have in-memory area, there is a parameter by the name of in-memory size. So you have to activate that parameter, or you have to enable that parameter by setting a value. So this value that you have to set is minimum 100 MB. So is it really needed for you to have this parameter enabled so that you can enable this component or memory structure within SGA? Well, it depends whether you want to use in-memory columnar store. So in-memory columnar store is a different feature that enables your Oracle database. Right now, this is in-memory, right? So it is within SGA. So you are talking about keeping content within memory, within cache, right? So conventionally, we store data in row format, right? I mean, row in the sense rows, right? So you will have columns and rows. So when just imagine how when you change your rows into columns, right? So this is more appropriate for data warehousing, right? When you're doing bulk operations, when you're doing batch operations, which are more relevant for data warehousing, there is a significant gain that you're going to have if you store your data instead of having it in row, right? Row mode, you can store them in columnar mode. So that is where the in-memory columnar store or in-memory column store will come into play. Okay? So therefore, if you are to do analytics, if you are to run analytical queries against your database, which is just a conventional OLTP type of a database, then still you can make use of the in-memory columnar store by converting your row formatted tables into columnar formatted tables within your SGA, right? So that will be done using in-memory columnar store feature, right? So if you're dealing with that only, you'll be requiring this parameter to be set to a minimum of 100 MB. So I'm emphasizing the value 100 MB because if you are trying this feature out, make sure that you have at least 100 MB set, because once you change this parameter, maybe if you have set a lower figure than 100 MB, your database instance will not come up. So you have to do some additional work in order to make it started again. So therefore, in case if you are changing the parameter, make sure that you have 100 MB at least set for this parameter value. So the one below, the command below, is basically giving you an idea as to a particular, parameter value representing your SGA components, whether those parameters are dynamic, meaning whether you can immediately change those values so that it will be reflected without restarting your database, right? So I've just taken few examples only. Now, for example, as an example, you can see the in-memory size. You can see, so there are 4 columns here. You can see the value. And then you also have the is session modifiable, is system modifiable, is PDB modifiable, or is instance modifiable. So what this means is that, right, whether the parameter value can be reflected or can be affected to your spawn session. Right? You don't go into any other level to only to your, you want that to be applied only to your session. Whether it is possible to do so. Right? You can see all these 3 parameters that I have derived are false under each session modifiable, meaning it cannot be modified at your session level. Right? User session level, you can't modify. Is it possible to do it at a system level? Right? When you say system level and you see immediate, those are the parameters that can be immediately changed with the alt system command. Right? So in other words, those are the dynamic parameters. Right? And then similarly, you have each PDB, which means you have one container and multiple PDBs. Whether you want to, whether this parameter can be changed at individual PDB level or not. And here we talk about at individual instance level. So individual instance means a database can be accessed via multiple instances also, which we did not discuss here. So that will come into play if you're talking about Oracle real application clusters. So it's only related to cluster instances. So now what you have to figure out is with this command, you can put your other parameters as well. However, I just took only 3 of them within SGA. So these parameters you can see is session modifiable immediate, right? Indicating the possibility of an alt system command, which will immediately change these values and which will reflect the values within SGA. But for some reason, the in-memory size that you're seeing here, although it shows immediate, you can try it by yourself as well. Is session modifiable is not possible, right? You can just try it out, which means if you try to change with the alt system command for in-memory size, it will give you an error indicating that it cannot be modified. So it cannot be modified in the sense it's not that it is not modifiable, but you need to update what we call the parameter file first and redo a restart so that those parameter values will be then applied to the database instance, right? Which means it is more of a static parameter, and it's not, the change is not immediate, right? So there's an exception there. I don't know why, or maybe like, I don't know, it's a bug or whether it is something that Oracle had not thought about as yet, but something that you also can try whether this can be changed dynamically with the order system command, applying it immediately, right? Okay, fine. So the rest is true. Shared pool size and DB cache size can always be modified on the fly. Okay. Now, going into the breakdown of the SGA components. So the first thing what you find is the shared pool size. Let me just take you back to the original or the second or the third diagram which I showed you. So here we are going to talk about these components, right? Again, we may not have enough time to go through all the components, but I've just picked most of them. And then we'll see what they actually can do. Okay, so the first parameter that you are seeing, or first component, what you are seeing is the shared pool. So what I have highlighted here, or the points that I've given here, these are the parameters representing those structures, right? For shared pool, we have a parameter called shared pool size. Okay, so shared pool size basically does caching of your SQL code, right? So when you run your code, you first have to, convert that into machine readable form, and then those have to be compiled. So this compiled code, we call that as the parsed code, will be stored within your shared pool, right? And when you are running this, you need to also understand the metadata about the objects that you are accessing. For example, what tables you are accessing, whether those tables have right accesses, right permission, right? How many columns that a particular table that you're accessing would have. So that is basically about data dictionary. So it's not really data, but some definitions of your data that you're going to access. So all this information or piece of information will be stored within this component called SGA, the shared pool size. Okay. And then we also have an optional component or optional structure within SGA, which we call streams pool, which we will use for buffered queue messaging, right? So this messaging will take place specially on some tools which we use. And these are like the Oracle Golden Gate. And if you have heard of Oracle Data Pump, for logical data exports and imports. And Oracle Golden Gate is basically for replication, replicating data from one source to another using a logical mechanism. So when you are dealing with these types of tools, your streams pool will come in handy, right? So there will be some messaging, information that will be stored within this component, and you make use of that in order to control communication for tools such as OGG and data pump. So do you really need to have streams pool if you don't use these tools? Not necessarily, right? So therefore, by default, the streams pool size will have a zero value, which means it's not allocated. But in the event, if you are really using these types of tools, you can dynamically increase the size of the streams pool. So when I say dynamically increase the size of the streams pool, always you have to remember, we first talked about the total SGA allocation, right? I told you that we have in the examples that I just took, we had about 800 MB allocated. So it will be the maximum. So 800 is the maximum. So within that, you may increase or decrease sizes. Obviously, if you're increasing a size of streams pool, for example, you might have to compromise the size of another component, maybe a shared pool, right? So that is how Oracle will do the adjustment, because you have a top allocated size, or limited. You have a limited size allocated, and within that, only the adjustments will take place. So another optional component, which is a Java pool. We size the Java pool using the Java pool size parameter, and that will be used in order to store Java code. So when you're using JVM, so when sometimes applications will use JVM, so Java virtual machine. So if you're using JVM, you have to enable the Java virtual machine component within the database as well, right? So once you have allocated, you will also have your Java objects created. So Java objects will have its own data dictionary as well. So all this information will be stored within the Java pool size. So again, is it necessary for you to have a Java pool size defined? Not really. Suppose if you're using JVM or Java components, then only the Java pool size have to be created. Therefore, the default size of Java pool is 0. Because you don't need to unnecessarily allocate memory to those components which are not being used, right? So that you will have enough memory to the rest of the components within those dynamic components that I just explained earlier. And then we also have vector memory size, which is coming along with 23 database version 23 AI. And again, it is optional. So why it is optional? So there are vector indexes, right? So I think we will have a separate session on vectorization, vector embedding, and how we really make use of vector databases, or vector columns, or vector values that you have in order to make decisions through Gen AI. Okay. So we will have separate sessions on that, but these are early days for us. Still new, and early days in the sense we are still trying to cover the fundamentals here. So probably in a future date, we will discuss in detail about how we can make use of these vector values, right, for Gen AI purposes. Anyways, obviously, when you have data stored, in order to improve performance, you use something called as indexes, right? So there are, for vectorization, also there are indexes available. So there are one of the vector indexes is HNSW, and we also have so HNSW. What do you call those? This particular index is more into memory, so it is residing in memory, and we also have IVF indexes. These IVF indexes will be used in order to improve performance of vector searches, right? So either way, if you are using these types of indexes, right? So these types of indexes, then you will be using your vector memory size as well, because in order to reside index caching and index itself inside your SGA, then you need to have your vector memory size defined appropriately. Okay, right. So moving on with the same discussion, some more components, right? So we discussed, we had an earlier look at the database cache as well. So the database cache is one of the critical components within the SGA, right? So why we have a database cache? So database cache is defined by the database cache or DB cache size. You can see there's one line here. This is the default DB cache size parameter that we set. Although you see a value of 0 here, dynamically the values will be given to these components. What you see here are the minimum value. Okay. So you can also override this. Maybe you can make 0 to maybe 1 GB. So that is going to be the minimum value for that component. So, but giving more flexibility, we don't give values to these components. Let Oracle decide what is the right size for DB cache or shared pool for that matter, and dynamically adjust it based on the maximum limit we have specified in the SGA. Sorry. So then we have, so we were talking about database cache. So database cache is basically a set of buffers. Now we saw there was a line item in when you type show SGA indicating buffers, right? So buffers are the slots where you can hold the blocks, right? So by default, your database block size is going to be 8K. So when you want data to be retrieved, the server processors, I think I told you a little bit on the server process as well at the beginning. So the server processors on behalf of the client process or the end user can fetch the blocks from the disk and place them in these buffers. Right? So these are these DB cache buffers that we're talking about. Right? So in the event if when somebody requests for a particular block which has the data that they want, if the block key is readily available on these buffers, we call it a cache hit. But in the event if the block key is not available in this SGA or in our database cache, we call it a database, sorry, a cache miss, right? Why cache miss? Because it is not available in the cache. So if it is not available in the cache, somebody has to retrieve that from the disk to the cache first and then to the user, right? So that is what I said. It is the responsibility of the server process, right, on behalf of the end user to retrieve the block or set of blocks from the disk and place them in the database cache, and thereafter it can be handed over to the client process. Okay, so we have cache misses and cache hits as well. And then we also have something called as LRU hit, LRU list and hit count, basically to determine how long you're going to keep your blocks in these buffers. Now, say, for example, we all know that we have a SGA maximum size given. So once the maximum size is given, that means we have a limited space. So let's say Oracle has decided to give 100 or let's say 10 GB of the SGA space to database cache. So we know that maximum blocks can be stored in the database cache is 10 GB, right? So in order to maintain proper cache, meaning there could be a certain set of blocks that you have retrieved long time back, but that now they are not being accessed at all. Right? So we need to understand here, accessing data from the disk is always going to be slower than accessing them from the memory. So that is why we are just caching them in the database cache so that it will be fast access. So always we need to make sure that only the frequently accessed blocks are being cached. Right? Old ones have to be flushed out, right? So that is why we maintain something called as the LRU or least recently used list, as well as the hit count to ensure that old blocks that are there on the buffers are getting aged out. Okay. Then we also have something called as buffer pools, a part of database cache itself, right? You can see there's DB keep cache size, right? And also DB recycle cache. So these are two of the components that will determine whether blocks of a certain segment. Now segment, let's say as an example, a table, right? You have a particular table that will be accessed, but you can tell Oracle that, the blocks that you access from this table needs to be retained within our cache, within our DB cache for a longer period of time. Okay. So therefore, what I can do is I can assign the blocks of, let's say, a table called employee to be retained in the pool called keep pool, right? So maybe there's another table by the name of department, which I hardly access. I do access, but I don't need to keep them, for a long period of time within cache. So I can allocate the blocks of data, department table to be reside inside the recycle cache. So those will be aged out fast, right? So at the same time, you may, I mean, it's not necessary for you to determine for each and every table whether that table's blocks have to go to either keep pool or recycle pool. It's not mandatory, right? So this is like if you really want to keep them for a long period of time without getting aged out, or because normally what happens is this. If you are not accessing a particular set of blocks for a longer period of time, with this LRU and the hit count mechanism, they will get aged out. But the moment you bring them or bring a table blocks, a set of blocks to keep cache, although you have not been accessing these blocks for a longer period of time, they may not get aged out. That's the difference. Okay. So you can determine what blocks of tables should go to keep cache, what set of blocks that you should be kept in recycle cache, and the rest will go obviously to the default cache. Right, so it's actually a segregation of the database cache where you will have your blocks stored based on the level of demand, right, or the frequency or the length of time that you need to keep within your database cache. We also have something called as non-default pools where you can define, because I told you the default size of a database block is 8K. So the buffers that you have in your database cache will cater to 8K blocks. But there could be certain set of, some requirements where you need to define blocks for tables, let's say 2K. So why a small size block size allocated for such tables? The reason may be the amount of data that you access is very limited on those tables. Similarly, if you take a table that you will be accessing very frequently and all the data of the table is required, then it's better to have a larger block size, because in one go or in very lower number of IOPS, you would be able to retrieve many blocks. I mean, you'd be able to retrieve blocks with a minimum number of IO attempts when you have a larger block size. So larger block size will carry more number of records. Okay, so it depends on the situation. You can determine whether you need to have a custom size, blocks for your tables. If that is the case, you first define your cache, appropriate cache, and then you can tell these tables will be sized or will be, will use 2K block sizes. Another set of tables might use 4K or 16K or 32K. So you can have multiple pool sizes determining various block sizes, right? So again, depends on your demand capabilities, right? Or data access. And then we also have database buffer. Now I told you buffer is a slot where you keep your block. Any block buffer will have a different status at any given time. Okay. One would be unused. Unused means the buffer is clearly empty, right? It had never been used. So you can easily take a block from the disk and that can be kept or can be placed on this unused block. Secondly, we have a clean block. Clean buffer. Clean buffer means you have a block residing inside that block, but it is clean, it is consistent. You have not modified it, or a situation where you have already modified it and you have already issued a commit against that. So that means the block is consistent. It is not in a intermediate state. At the same time, a buffer might carry blocks which are dirty. We call them dirty buffers because those blocks are changed in those buffers, but they are not committed as yet. Right? So if it is not committed, it's not in a proper state. People might commit or user might commit on commit, right? But the changes have happened, but it is uncertain whether this is going to get committed or not, right? So buffers holding change blocks, which are not committed, are called as dirty buffers. Okay, so I'm emphasizing on these technical terms simply because these are really needed when you progress, because you will come across, for example, cache hits, cache misses. Whenever you hear that technical term, then you know what we are really talking about. Right? Similarly, whenever you hear a dirty buffer, now you should understand what I'm talking about. Right? Then we have buffer modes. Right? So the buffer modes can be current or consistent. Again, current means it is the current version of the buffer that you are accessing, right? Now, let's say as an example, something like the dirty buffer, right? So you are doing a change, right? You are doing a change, but then you are probably not committed, right? You have updated your employee table 2 records, and one block was affected by this change. Now, if you take that buffer, that change reflects, right? So if you query the table, you are the one who did the change. So if you query the table, you see that block, right? So that type of a block is what you call DB block get, right? Where you are seeing such data in a current state, right? But at the same time, let's say since you have not done a commit, if another user wants to access the same set of records that you've been accessing, they should not see the changes you made. Why? Because you have not made the changes permanent, right? So until such time, others should see the before image of the change, which is in a consistent state. Right? So similarly, therefore, when it comes to buffer modes, you see consistent blocks or consistent reads when somebody else fetches the same set of rows, but this time it will not be the same block that you have modified, but a different block that has a previous image. So hope what I'm saying is clear to you. So such reads are called consistent reads. Theoretically, the consistent reads will be coming mostly from undo table spaces or undo images, right? Because whenever you are doing a change to a block, you are doing changes to records, but the records will be belonging to a block or a set of blocks, right? So when you are doing that, then before this change occurs, there will be a before image kept inside another area, which we call undo segments. So a consistent read most likely will come from a undo segment. Okay, right. But the DB block gets will always come from the DB cache because that is the place where you have change data residing. Okay, right. Okay, then we have access modes. Okay, so I'll give you one example for a pinned buffer. A pinned buffer is when you access the block. You are accessing the records of the block. Maybe you're doing modifications or maybe you are just doing access, right? You are doing record access. So until you are finished with your query, the buffer cannot be flushed. It has to be locked, right? Until you finish with your work with that block or set of blocks. So that is called a pin buffer. If the buffer is being currently accessed by a session or group of sessions, then the buffer is called a pin buffer, right? Otherwise, if the buffer is not being accessed by somebody, then it could be, it is treated as a free buffer. Okay, so there are various forms in which the database cache will carry its buffers and data, right? So these are different forms of it. Okay, so based on your requirement, you would be able to configure your buffer pools. You might be able to have your own non-default buffer pools, right? According to the requirements that you have. So these are some of the, these are buffer cache components that you have. So you may not go and change these figures all the time. So you need to have your need as well. So according to the need, you'd be able to change your settings. Okay. Right. We also have something called as log buffer. So log buffer is, I told you that the value that you have here is a static value. So the default value which Oracle gives you is currently, is sufficient, right? We don't need to go and modify it unless there is a specific requirement of changing for optimization, right? So it's a circular buffer, which means the content of the log buffer will get flushed. So what basically it carries? It basically carries information that will help to regenerate a transaction. Let's say you are doing an insert to a particular, maybe you are doing a deletion to a table. So information such as what was the previous value, what exactly the location you are changing, and what is the new value that you are bringing in, right? If you can capture those few information, that will be sufficient for you to regenerate the transaction, right? So that piece of information will be separately tracked and will be recorded initially in your redo log buffer and will be later on flushed into the redo log files as well. So that's a different process. So if you have such information, right, where you can recover transaction or you can regenerate a transaction, even if transactions that were committed gets lost within your instance, because instance, we discussed that there in instance is running on memory. So there's a possibility of losing the memory and losing all its content for your cache, right? So maybe you might have dirty buffers which were still not flushed onto the disk appropriately. In such cases, you may doubt whether whether your transactions would get lost due to an instance crash. Not necessarily, because it is separately captured within log buffer, and that will be flushed onto the disk as well. So that in any case, if a particular recovery is required, this redo content can be retrieved, and and automatically the changes can be reapplied appropriately to make the database consistent. Okay, so that's also an important section or important component, but it's a static value which you, if you really want to change the value, you need to restart the database after changing the log buffer parameter. And we also have the large pool size used for distributed transactions and also for parallel queries. And also when you are invoking RMAN for backup and recovery operations, you'll be leveraging large pool size. So again, if you are using these tools, you need to have appropriate large pool size defined. Okay, so so this is not really a session to determine what's the best value for these components, but I'm just telling you, in case if you are, for example, in case if you are using RMAN, then read about large pool size, how you can size it appropriately to get the maximum amount of RMAN operations. Similarly, if you are doing parallel queries against your database, then again, maybe you can read about large pool size to determine the most optimized size for your operations. And then you also have data transfer cache size. So data transfer cache size is more or less important for data guard configuration. So data guard means you are setting up or you have a standby database supporting your primary database, having changes replicated from the primary side to the standby side. So in such cases, sometimes there could be objects that you don't capture the changes. If you can recall, when I was talking about redo log buffer, I told you about tracking the changes. So there are some objects where you have explicitly asked not to capture changes. So if you don't capture changes, there is an advantage because you don't generate a lot of redos, right? But there's a disadvantage in the event if the named object failed, then you don't have data to recover, right? So you don't have data to recover, and therefore there could be challenges there. So you can see I have given a armament command which is recover database no log block, right? So this will basically enable the standby database to fetch changes from the primary database in the event if you are going to recover objects that have been marked as no logging objects, right? So okay, so I would say that sometimes the recovery might be successful, sometimes it might not be successful. But the parameter here, the data transfer cache size, will determine the availability of cache in order to send data from the primary site to the standby site. Okay, so again, this is not a compulsory parameter to be set, but something that you find within SGA. Okay. So moving on to our last section, which is the dynamic components of SGA. Again, I told you that there are certain set of parameters such as your shared pool, right? Your database cache, your Java pool, right? And there are certain other components of components within SGA that can be in your $V parameter. You can figure out whether the parameter is under the section of is system modifiable. If that is immediate, that means those are all dynamic parameters, except for the in-memory cache, which I explained to you early, which you also can try out to see whether it can be immediately changed. But I wasn't able to do that. Okay, but anyway, the SGA dynamic components, right? You would find the component that can be dynamically changed. What is its current size? What had been its minimum size and the gone up to which maximum size? And then how many times it had got either shrunk or it had got increased? Because I told you a component might have to get shrunk in order to release that additional space to another component within the dynamic components of SGA, right? So all this information can be derived. And there's an important column as well, which is the granular size, which I couldn't explain earlier. So the granular size is basically to determine the figure that you're going to increase. Now, as an example, if I ask my SGA to increase by, let's say, by 5 GB, right? Or maybe let's say 100 MB. Right? I want it to be increased by 100 MB. But when you do that, and when you check the figure, it might not exactly be 100. It could be, let's say, 105 or 110, because the increments are happening at the level of granular levels. So you have a granular, you can figure out, you can see the granular size when you query this view. So it will be multiples of the granules. So if your granular size is 4 MB, it will be always in the multiples of 4 MB, right? 4, 8, likewise, right? So if you want to have a 10 MB increase, if my granular size is 4 MB, you will get 12 MB as the effective size because the granular size is 4 MB, right? So that is where the granular size will come into play, because sometimes you might want to increase up to a certain limit, but you would see once the change had been done, although you requested X amount, it had given a Y amount simply because of the granular size. Okay, so these are some of the areas that I wanted to highlight today in the section of SGA components. I think we have just run out of time as well, but feel free to take up questions if you have. All right. So if there are no questions, Azir, I think we can wind up for today.
Yeah, generally they are not asking question, Gan. It's a general
So
practice for
I
them.
have a small question.
Yeah.
Okay, go ahead.
So the dirty records are not sending to the redo buffer, right? Only the changes are sending, right?
Okay. So so when it comes to dirty buffers, so dirty buffers means a buffer which carries change blocks, right? Now let's say as an example, let's say you are doing a modification to your employee table. So I usually take employee table and department table, right, as examples. So you're doing a change to your employer table and you're modifying employee records 1 and 2. Okay. So the first thing what Oracle has to do is to figure out whether the block is readily available in the cache. All right.
Okay.
So if the block is readily available in the cache, I'm just saying that we're just assuming that this is the first time the table has been accessed. Okay. So which means that the block will never be, block will not be there in the DB cache, right? Because it has not been accessed before. Yeah. So which means that it's a cache miss. Right? So on behalf of the client process who's requesting this change, the server process will now go to the disk and fetch the block or set of blocks that carries those 2 records. So most likely, since we are only talking about 2 records, the 2 records will be there in a single block. We'll assume like that. So that block now comes into the database cache. Okay? Yeah. So once that happens, now you need to do changes, right? 2 records will be modified. Yeah. So just before the modification happens, the process would be first, Oracle needs to take a copy of the previous image. So the previous image will be kept inside this segment called undo. Right? Okay. And now it will start doing the change to the block. So the moment it starts doing the change, that buffer will get dirty. Yeah. Right? So at the same time... But it keeps the copy, right? Yeah, the original copy will be there in the undo segment. Okay. Okay. So now what happens is that while the change is in progress, Oracle will keep a track of the change that you're doing. Okay. So that change or the tracking of that change will be recorded separately on the log buffer. Yeah, redo. Okay. First to the log buffer. Yeah. So then there are, frequent events such as, in every 3 seconds or in every, when 1 MB is full, when the log buffer is 1/3 full, there are certain conditions, right? Okay. Where the log buffer content will be flushed to the disk. That will be to the read log files. So that is going to be the process. Okay. Is it clear? Yeah. So the changes will be gone for the redo log buffer, right? Yeah. So the tracking of the changes will always be there in the read log buffer. Okay. Read log buffer to read log files afterwards. Correct. Yeah. Thank you, sir. No problem. So thank you for that question.
Yeah. Can sometimes that the student might get misleading about that name called dirty. I think it's a changed buffer, right? Yeah.
Yeah. The moment you do a change to the block within the buffer, we call it a dirty buffer.
Dirty buffer.
So dirty buffer will become clean also once it becomes consistent. So the moment, because that's a different interpretation as well, because normally what we say is that dirty buffers have to be flushed onto the disk to make whenever a checkpoint occurs. So, so from a different interpretation, the buffer may become clean once it becomes consistent, meaning when you commit as well. But from a different aspect, the moment a block within a buffer becomes changed, we call it dirty buffer.
Yeah, thanks, Sahan, for asking that question. Because any other question, you can ask a question from any language. It doesn't matter. So the important thing is you get an idea about this component. This is very important component. Gan is the best person to deliver this subject. So I'm also not deep dive in this end. So thank you again. So any questions you can ask in Sinhala. සිංහලෙන් අහන්න පදරුවනි මොකද මේ ඔයගලන්ට මේක ප්‍රශ්න විසඳගෙන යන්න මේ මේකේ අල්ටිමේට් ගෝල් එක අපි හොඳ DBA ටීම් එකක් ලංකාවේ ඇතුලේ හදන එක මේ so you can ask any questions. Kavidu, you asked me some questions. Do you have any?
Yeah, I was actually reading about some, but because you mentioned to read about the large pool size. It was about tuning the performance in an R-man backup. So, say like there's a requirement for perform an R-man backup during work time. So, will the tuning the large pool size help us with the R-man performance and the overall performance of the database in the other operations as well?
Yeah, so that's a good question because the problem is that because of the dynamic nature, right, large pool size might tend to grow because of R-man operations, because now large pool is a dynamic parameter, right? A dynamic component.
Yeah.
So therefore, although we have set a minimum value of 0, then in the SGA Oracle feels that you need to give more space to your operation, then you might, Oracle might take to increase a large pool size by compromising the size of, let's say. So yes, so therefore, in such cases, there could be a certain impacts on the overall performance as well. But the thing that you have to understand is this: now, when you are configuring your, when you are configuring, so generally, if you take R-man as an operation, when you're performing the operation, you can price what exactly R-man needs to do, whether you want your database backup operation which is running to be taken as a priority operation, or whether you want to prioritize your normal work. Okay, so there is this component by the name of resource manager. Yeah, so there is a component called resource manager who is. So it's a big topic to discuss now today, but probably maybe later on we will try to address that. But with the resource manager, you can allocate certain resources or certain operations to be prioritized. Okay. At the same time, even within R-man command itself, you can prioritize whether you want R-man backup to be completed as soon as possible, or whether you should not compromise your day-to-day work and R-man operation to be completed, in a longer period of time. So likewise, you can determine. So there is no direct answer for this question, but yes, there could be an impact in case if the shared pool becomes extremely big. And because now large pool will not really help optimization of queries, right? Large pool will help obviously your R-man and certain set of what you call parallel queries, but generally speaking, it will not will help right? When you have a large pool, your optimization of your queries. But there are ways and means in order to mitigate this, and the ways and means to determine how large pool should behave. So, and we can also, let's say, if you have a, say, for example, if we, probably with our experience, if you know that large pool at least requires a certain amount of memory, then we can reserve it as well. So maybe you can have a better shared SGA size given, and out of that you can give a reserves now. Now, by default, large pool will have a 0 value. But I can always say large pool should have at least 1 GB. So that will be reserved for large pool then. So equally, you may increase the total SGA as well to give buffer to the rest of the components. Right? So there are ways and means to control this, but you have a valid point, because if it dynamically grows, there is a possibility of impacting your normal operations.
Yeah. Okay, Cam, thank you.
You can stop the recording. So
yeah,
guys, you can ask question. That's not related to that questions. So